MAC addresses and ARP. What is a MAC address? A MAC address, Media Access Control, is a 48-bit hardware identifier assigned to every network interface at manufacture. Format, AA, BB, CC, 11:22:33, 6 pairs of hexadecimal digits. First 3 bytes, OUI manufacturer ID, AA, BB, CC equals vendor, last 3 bytes, unique device serial. MAC addresses are local, they only matter on the same network segment. Every router hop uses different MACs. PCA wants to reach PCB, PCA wants to send data to PCB at IP 192.168.1.20. It knows the IP address, from DNS or static config, but to create an Ethernet frame it needs the MAC address too. PCA checks its ARP cache, a local table of IP MAC mappings. PCB isn't there yet. Solution: send an ARP request, a broadcast asking, who has 192.168.1.20. Tell me your MAC. ARP request, broadcast to everyone. PCA sends an ARP request with destination MAC FF, 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 the broadcast address. Every device on the LAN receives this frame. The request says, I'm AA, BB, CC, 11:22:33 at 192.168.1.10. If you are 192.168.1.20, please tell me your MAC. Every device reads it. Only the device with IP 192.168.1.20 replies. ARP reply, unicast response. PCB recognizes its IP in the request. It sends an ARP reply directly back to PCA, unicast, not broadcast, since it now knows PCA's MAC from the request. Reply: I have 192.168.1.20, my MAC is DD, EE, FF, 44:55:66. Both PCs also update their ARP caches. Future communication skips the ARP exchange. Now data can flow. PCA's ARP cache now has the mapping, 192.168.1.20 DD, EE, FF, 44:55:66. It can build a proper Ethernet frame and send data directly. ARP entries are cached for a few minutes, typically 20 minutes on Linux, 2 minutes on Windows, to avoid constant ARP storms. ARP has no authentication. ARP was designed in 1982 with zero security. Any device can send an unsolicited gratuitous ARP, claiming any IP's MAC mapping. This enables ARP spoofing. An attacker poisons your ARP cache, making all traffic go through them first, man in the middle. Defenses: dynamic ARP inspection, DAI, on managed switches, static ARP entries for critical hosts, or IPv6 NDP, which replaces ARP with better security. If you found this helpful, try the interactive simulator yourself at Packetlab.io, it's free to use. See you in the next video.